Ladies and gentlemen, good evening, and let us play with Google Vertex and let us call a trained model with Python. Doesn't that sound like a lot of fun? You probably have seen the other videos that I made in this Google Vertex series, where I took 90 pictures of random dandelions and rocks and signs. Traffic signs and also grass, and then I placed these into a data set on Google Vertex, and then I trained an existing model with those images. So I chose to use an existing AutoML model. Then I trained the images, and then I got this cool. 1 hour later, then I got this awesome model. And the reason why I think it's awesome is I think it's awesome that just with 90 images, that a model that is actually this precise can actually be made. And of course, best practice is to have 1,000 images per category. And this is of course the image classifier that I'm using right now. I have some images and I want them to be classified and labeled with the correct label. How do we do that? I've already shown you how to do that with REST and with curl. If you didn't know how to do it, so first of all, you would actually go to your Google projects, then you will find your online prediction right here. Go to online prediction right there. Then you will find your trained model. This is the one I have right here, rock and flowers. Then you just press sample request if you don't know how to do this already. So then you press sample request right here, and then you get this awesome help right here. You have to follow. There's a guide you have to follow, and what this guide says, it actually just says that you have to have Python 3.8 or newer on your machine. That's fine, and then it also says that you should add there's a library that you have to add, or there's a requirement that you have to add to your requirements.txt file, which is Google Cloud AI Platform. Then you can just have PyCharm to import it. Of course, I'm using virtual environment, so you don't have to use PyCharm. You can just use another IDE. Then you just have to activate these things, and you have to import or install these things manually. Of course, you can also point to the requirements.txt file with shell commands. It's just a bit easier with PyCharm. So the next step after doing that, then the next step is to copy one file that these Google wizards has made, and so you have to copy one file. And that's just to make it easier, so you don't have to worry about the API and how to actually use it, because there's a lot of cool help right here. And this is the file right here, predict image classification sample.py, and you just copy all of this, copy raw. And I have done that, so I got this file right here. So here's my file right here. And if you, it is really good to understand how the API actually works. And of course, you can change. You can easily change some of the code by just reading all of the comments. It's well commented. For instance, if I want a lower confidence score or confidence threshold than 0.5. Then I will just find it right here in the code, and I can go and minimize it. This means that then I will get also the labels for the confidences that are lower than 0.5 if I lower the values, of course. Okay, so far so good, and this is just Python code, right? It's a function that will just help us to actually to create a prediction on an image that we have locally on our own machines. Or if I should go through the code, then let us just go through the code. Let us not go through the code, because we want to see the result, actually. That's more fun. So first of all, I have one image right here of a dandelion. And then I have my main Python class right here. Python file, sorry, not a class. And here I have the usual if main. This just means that if it has been run from another package, then this code will not run. If this is the initiating package, then this code will run. And then I'm using that function that we just had, that we stole, or not stole. We were allowed to do that. So what we took it from the Google guys and girls, the Google wizards. So here we have the from. Here first of all we import it right here. So we say import. I place it in source utils. That's why we have this package structure right here, and then we have that is the name of the file, and then this is the name of the function. I should have named the file something else. It's a bit confusing, I can see that. Nevertheless, it works because so the next step, these values right here, where did I get those from? And if we open up our Google console again and press, if we go back right here, then you can see we have a little code snippet right here, and that is where we get all of these values right here. We have a project number, project ID, then we have the endpoint ID, the location, and then the file name that you have to put in yourself that you want to test. You want to check what kind of label will this get. So that this is the last part right here, and that was how I got those values right there. So let us go here. Let us just run the mic. Let us see what it looks like. Okay, I'll do that. So first of all, the application is using the credentials placed on your own machine. So that means that you have to log in. You have to authenticate yourself with Google. So you can write Google auth or gcloud auth login if you haven't done that already, and then the credential would just be taken from your machine. This means that if you're running this inside a Docker container or something like that, then you would need a service account. You would have to export the service account JSON file, and you would have to place that in some folder, and then you would have to point that to that folder, to that file, of course, with an environment variable. If you're just playing with this on your own machine, then you can just use your own credentials, just as long as you have logged in with gcloud auth login. Okay, so let us look at the response right here. So we get some response. This is the model ID. Yeah, that's fine. Here we get the prediction confidence with 83% confidence. This is a dandelion, and the model is totally right. That is why I think it's awesome, because it's quite right, and I didn't take that many pictures, right? I didn't take that many images. So let us try the rock on grass. I think there's one of them that is a bit tricky, and that might be the one that I should use. So let us take the rock on grass, and I'll just copy it right here. Yes. Why did I rename it to image.png now? Okay, let me just rename that to rock on grass.png. It's a bit weird. It changed the last name also. Okay, but that is okay, I guess. So now we take the picture. Let us see if I can actually handle the rock on grass PNG file. Let us see what we get now. Now we run another prediction. And of course you can use REST, so you can also use any programming language that you want to. And in this situation, it is a rock with 95% confidence. So this is awesome. It's very easy with Python. And again, feel free to take my code from the GitHub as usual. There will be a link to it in the description below as usual. It's really, really awesome. It's easy to use. The Google Vertex right here. It just makes it makes you much more efficient compared to if you had the TensorFlow. If you use TensorFlow to first set up and create your own model, because there are smarter people than you out there that can actually knows how the best image classifier model is made. But of course there can be some corner cases or some really weird situations where you have to use your own data scientist, and they will make their own model, and of course you can do that. Then you just create your usual TensorFlow model, and then no problem with that. You still have to go through the same process. You have to create a data set where you have to label these files with the right label. Then you have to train your model, and that can easily be done still with Vertex, even though that you're using custom model. Doesn't matter if you take a model from the shelf. I used AutoML, or if you use your own model and your own customized model and develop it with TensorFlow. My guess is that the AutoML in most cases would actually give you the best result, because they have when you're creating these models, you have to define something called hidden layers, and of course there's also the input layer usually gives itself, and also the output layer gives itself, because the input layer, that is what you are putting into the system, that is usually an image with a number of pixels, so each pixel and each color value will usually take one neuron in the input layer, but then you have the hidden layers afterwards, and that is the difficult part. How many neurons should all of these hidden layers be, and how many hidden layers should you actually have? I've made another video with TensorFlow where we go in, where we look at that part, and it is actually quite difficult, and a lot of times it's just up to, you have to experiment, and you have to, a lot of trial and error involved in that. That's actually it. That is what I want to show you. Python is easy to use with Google Vertex API. And right now, just one thing, right now use the Google Cloud AI Platform API. If you want to, you could also call it with REST directly. I would not recommend you to do that, but you can do that if you want to. And there are actually some curl, we have some curl commands right here in the root of the project, or not the root, in the flowers and rock folder. Here we have something with try rock right here. So here we have some curl commands. So if you want to use curl instead, or if you want to use REST calls, then you can just do exactly what this curl command is doing, and then you'll be happy. Thank you very much for watching, and thank you very much for all of your comments. Yeah, they really make my day. So thank you very much, and have a great evening. And I hope to see you again soon. Bye bye.